All right. Thanks for coming this intro training session. My name is Song Park, and I'm very excited to invite you and give you these lectures. I can promise you that this 1.5 hour will be very beneficial both you and me. Please take a listen to my lecture very carefully, and if you have any questions, just let me know through my email. My email address is swpark@midasuser.com. Also, you can send me an email through ts@midasuser.com. So once you become our client and start off using MIDAS Civil, you might wonder how to start this program and what would be the proper way of using this program. From those points, me and my colleagues invented this intro training. We have gotten many queries everyday basis. However, especially from our starting users, the primary concern has been how to create a model properly to get the reasonable analysis values. For example, the model as shown here is one of the queries I got the other day. Why the deformed shape looks strange. The concrete deck drops down vertically so much between girders even after the concrete and steel girders are composited. There was no mistake in defining loads or construction stage analysis, but this bridge was improperly assumed and designed. It was very tedious for my clients and me to go over 1,000 nodes and elements, and it took more than 2 hours to figure out what was the problem. In order for you to avoid this kind of mistake, you need to understand basic concept, but very necessary, and how to apply it to MIDAS Civil to create a model without mistake to save your time. So the objectives in this presentation comes from the fact that rhyme modeling practice obviously leads us to getting reasonable analysis values. In order for you and me to get to this point, we need to study first what is the general modeling sequence in MIDAS Civil. And as this presentation goes to the end, you will notice that all the topics I will cover will be connected and illustrated to support the modeling sequence in MIDAS Civil. It is also very important for you to know how to apply the basic concept to be explained today into the real application of MIDAS Civil along with the modeling sequence. Let me briefly go over the sequence of modeling a bridge. Creating a primary bridge model with a node and element is the first step. Next, you will check whether your model is well made without errors. If you find any errors, you need to revise them. Unfortunately, you may step into endless loop between check and revise step over and over again if you don't understand MIDAS Civil very well. Afterwards, your mathematically assumed model will be completed and go to analysis process. Today, I will be very focused on create, check, and revise steps. More specifically, my duty is letting you know how to disconnect the loop in your modeling sequence by giving you direct understanding of MIDAS Civil so that the analysis part will be covered in the next intro training sessions. Please join the next intro training sessions. I have kept saying understanding of MIDAS Civil is very important in the previous slides. So what would be the significant concept in the MIDAS Civil to model a bridge properly, strictly following the modeling sequence? First, even before starting off creating a model, you need to understand how to start new project and the basic frame of MIDAS Civil, which menus contain which functions and tools. Secondly, node and element are a major frame of a bridge model. Node and elements are needed to be properly selected and located in the process of creating a bridge model. Next, selection and view options are very powerful tools that you can check whether nodes are duplicated, which leads to singular error, or whether your element contains proper section and material properties. There are many tools you need to utilize professionally. Next, coordinate system is also important to know. In MIDAS Civil, there are different coordinate systems you have to know. Because node and elements are expressed through the coordinate system, you definitely need to understand different coordinate system to fully use MIDAS Civil. The faster modification in the revising step depends on how much you understand the coordinate system while in MIDAS Civil. So the summary what I'm going to talk about today is first explaining the basic frame of GUI, graphic user interface, with how to start MIDAS Civil. Secondly, I will summarize the concept of node and element and what is the key points you need to know. Next, I will talk about 3 different coordinate systems. Finally, I will go over the basic concept again by using MIDAS Civil and show you what are the real applications by using an example model. Now I will be focused on graphic user interface and show you what's the tips for starting MIDAS Civil. As soon as you open up MIDAS Civil, you can see the file button. From here you can start off MIDAS Civil by clicking New Project or pressing New Project icon right next to File button. Also, if you need to open up the model files previously worked, you can click Open Project or select a file among the recent document history. Never forget click Close Project as soon as your work in MIDAS Civil is done. If not, afterwards, you could not open the project file properly, and you need to send an email to us to request disconnection. Also, importing and exporting files are available in File menu. The general overview of the basic frame in MIDAS Civil is like as shown here. Under File button, Main menu is located on the top. Under Main menu and the very right side of the MIDAS Civil window, icon menu exists for users' convenience. All the functions on the icon menu are extracted from Main menu, which has been clicked most frequently from our users. On the right and left side, you can see the task pane and tree menu. Between tree menu and task pane, you can find the table window and model view. Under the model view, message window exists and status bar also. My challenge to this presentation was breaking down node and element because I think this concept is hard and the most important. First of all, I will explain how and what is the fundamental node and element property in MIDAS Civil. Secondly, with a micro perspective, node locations in a section will be explained. Finally, with a macro perspective, how node and elements are expressed in the user interface and what is the trick of them. Node is the essential component to illustrate a bridge model. Most of models starts from creating and arranging nodes. From more than 2 nodes, beam, plate, solid element can be defined. For example, beam element contains 2 nodes at the end of element, which are called I end and J end. The plate element contains 4 nodes or 3 nodes at the edge point of a plate. Solid element contains a node, as you can see here. The node plays a very important role to connect the same element when the more segments are required, or to connect the 2 different elements. There are many different types of element. Each element has different resisting availability to different types of force and moment. More details are explained in online help manual. While you're working with MIDAS Civil, simply pressing a phone key or buttons, and you can check all the information you need from the online help manual. What types of information can be included in node and element? First of all, as shown here, each node and element has their own identity by being numbered. Secondly, element type can be also defined with various element types, such as truss, general beam, tension only, or compression only, so on. Furthermore, material and section properties can be defined and stored in node and element. As you create the nodes and element, please keep in mind defining for information with a proper manner. Why node locations are important to be defined properly in section properties. Let's look at an example as shown here. The two example contains same material and section properties. However, as you can see here, due to lack of understanding in node and location, in node location in section property, in the bad example, the two interior girders goes up a little bit compared to the two exterior girders. Even the nodes are located on the same elevation. um, when you are modeling a steel composite girder bridge, you should keep in mind that nodal location on different girders should be on the top center to avoid the transversely fluctuating deck like in the bad example. So my question is how to modify the nodal location vertically and horizontally in the section property. This process takes place when you're defining section properties. Go to Section tab and select Section Property. Once you open up the Section Data dialog box, you can find the node location generally at the bottom of the box, which is called Change Offset. Click Change Offset and change the location from Change Offset box. The easiest way is to click Offset drop box and select the location where you want. Reflecting the previous example, you might want to select the center top for steel composite sections. Also, center location can be selected at either centroid, which means neutral axis location, or center of section, really one half of the section height. More specifically, at the horizontal offset and vertical offset, you can also define the reference line. Two extreme fiber is the most outer surface on the top in vertical offset and on the left in horizontal offset. Furthermore, if you have a tapered section, you can also define the node location at I end and J end. Finally, before close this box, by clicking display offset point at the bottom, you can check where is a red box dot, which will represent the node location in a section. Now let's get started with creating nodes. First over, on the blank whiteboard, after clicking create node button, you can set up the coordinate x, y, z. Generally, it starts from 0, 0, 0. From here, if you have an idea that how many times you will duplicate the nodes, punch a number on the number of times box. After that, you can freely set the distance between nodes at three directions, x, y, z. Most importantly, always you better to check on the box merge duplicate nodes and intersect frame element to avoid a singular error. If their two nodes are duplicated on the same coordinate, MIDAS civil will make two nodes as one node, or if their two elements are intersected, MIDAS civil automatically let the two elements intersected and creating one node at the intersecting point. Also, you can copy and move the node at transfers at translate node element button. In this function, copying the node is available at equal distance or unequal distance. Largely, there are three different coordinate systems: global coordinate system, nodal local axis, and element local axis. Global coordinate system use the capital X, y, z axis of the conventional Cartesian coordinate system with the right-hand rules. You have learned this concept in your engineering school, so I'm not going to explain the basic concept. However, I will put more time on node local axis and element local axis. Why MIDAS Civil invented the two more coordinate system and what they are and how you can use them. In global coordinate system, axes are expressed as shown here on the user interface and by the capital letters x, y, z in the tabular information. and the task pane. If the bridge is straight without any curve or irregular geometry shape, users are totally fine to use just global coordinate system. However, engineers frequently face to various geometry shapes. How can you deal with the irregular geometry shape or a layout to define proper support condition and get right stress or force values? The answer are in the node local axis and element local axis. Node local axes are used for defining boundary condition such as support um, or point spring support, so on. As shown here in the curved bridge, to obtain proper reaction along with the tangential to the curved line and reactions with radial direction, global coordinate system cannot be used. In this case, we need to define node local axis to get the proper reactions with the proper directions because support axis follows the node local axis. As you can see here, curved line have different element local axis. When you jump into design practice, you definitely need a cross sections perpendicular to the proceeding curved line in the each element to get axial force, shear force, or bending moment. Here, if you use global coordinate system, you cannot get the true forces or moment value from the non-perpendicular cross section to the curved line. So element local axis need to be defined for the right force and moment values. Uh, from the demonstration, let me first go over the GUI, element view, and activation options, also dynamic view options. Let me switch to the MIDAS Civil. So let me open up the MIDAS Civil right now. Give me a second. I need to adjust some screen resolution. All right. I'm ready to start demonstration here. So once you open up the MIDAS Civil, you can see this graphic user interface. I want to point out the license first. Once you click this button, register protection key here, and here is the two different license, web license and a hardware license. But these days, I heard that in 2015 we are providing web license. So first over, you need to create your user ID and password. So first over, if you don't have your user ID password, you can just click the create a new account on here, and you can make your account on here. And punch the proper protection key ID, and never forget to click the select product. It takes a little bit time. So once you open up the program licensing configuration dialog box, you can see the PID on here. Select the PID and just select the options on here. And your like a PID is changed from if you buy more license, or if you buy like a more modules or higher analysis tools, it will be changed. So please click the update button here. So we are ready to move on to MIDAS Civil right now, and click yes. And let me open up the one example. So first of all, I want to check the unit system. So as you can see here on status bar, you can instantly change your force unit and length unit on here. But how can you set up the default unit system? How can you set up the default your like a unit system? Go to tools and then click the unit system on here. As you can see here, length, force, heat, and don't forget to check on this box, set and change default unit system on here, and click this one and click OK. And your like a unit system will be like a change to the like a default setting as I did. And the next one is I want to point out the preference on here. So go to like a property and select the your like a proper standard. I mean, if you're in the US, you might want to select the ASTM and also concrete ASTM. And go to design, all the design code and load rating code H2LLFD, H2LLFR should be selected in proper way. This one is a default setting for you. So now let's move on to how you can rearrange the menu windows. So here, let me just move this message window to the top. So once you are pressing your button and move up to the top, you can see the blue box. Once you see the blue box, just release your mouse button and it goes to the top. And again, I will move down to the down. So in MIDAS Civil, you can use two tree menus, but most of users does not know how to turn on the second tree menu. This is very easy. Go to icon menu bar and click the right click, and you can turn on and turn off a tree menu like this. Also, how can you use the dynamic view options? So here, this is dynamic view options. So first of all, I will explain zoom in and out. So once you click this button, zoom in, as you can see, the bridge gets larger and larger. Once you click the zoom out, it gets smaller and smaller. Also, if the bridge is larger than whiteboard, you can just click the zoom fit. It will automatically get back to the original shape. And also here is a pen options. Click this button and you can move your bridge model from left to the right and right to the left. Also, you can see the hidden view by using rotation view on here. You can freely rotate your model. Also, let me turn on the node on here. Go to display and find the node tab on here. So as you can see here, this is you have to check on this box to see the node. Click this node box and click apply. As you can see here, all the nodes are displayed on here. And in order to see the connection between node and element, you can also use these buttons, shrink buttons. Once you click this one, as you can see here, there is a gap between the node and element. This element is just one. It's not like a connected. It's not a continuous element. Also, you can use the element selection and element activation. So how can you select your element and node? So this is a single selection. This is for selecting a single node or element. So once you click this one, and I'll just select the one element on here, and it is a red highlighted. Also, if you want to activate, or if you want to just see this element, just activate using activate button, as you can see here. And also in here, if you want to see node number and element number, turn on this button. Display node numbers. It says 853 and 921. And also you want to check this element number. Turn on this button. This one says 1501. And my final question in GUI is how can you see the real shape, real your like bridge model shape. So first of all, I will activate R and turn off the node number and element. And click the turn on the hidden button on here. As you can see, you can see the real shape of the bridge. And how can you change the color? Different section has different colors. So this one is very easy. Go to view, click display, and click again display options, and go to draw, and click section and thickness color, and click the random color and apply it. Now I want to explain how to import AutoCAD file and Revit file into MIDAS Civil. Go to import and click the before I need to close this project. Okay, and open up the new project. Now I will just import a file from the AutoCAD. So go to import and select the AutoCAD DXF file. And here you can find your AutoCAD file on here. I already made one file and a curved top girder pre-stressed bridge DXF file. Double click this one. As you can see here, here contains all layers. And if you wanna bring this exterior girder line to the MIDAS Civil, move to selected layers. In here, you can also define the material and section property. And also, you can define the original point, and you can rotate with the x-axis and y-axis and g-axis. Now I will import this Revit file to MIDAS Civil. So I convert this Revit file to the MCT files. So more details in online help manual, you can just refer to that. And I will just demonstrate whether it is work or not. Click the MIDAS and Civil MCT file. And as you can see here, it's the exactly same the Revit file. Now let's move on to creating node and check and revising steps from the scratch. Let me open up the new project again. So from the scratch, I will create a node and an element, And I will give you the understanding of how to copy and paste. I mean, the copy and move your node and element on the whiteboard. And at the final, like in revising step, I will show you how to change your section property by using tree menu and a table window. First, let me create 10 nodes on here. So go to node and element and select the create node on here. And the coordinate system, the default is 0, 0, 0. And I will just make the 10 feet span with 10 segment. So 100 divided by 10 is 10. So number of times should be 10. And a distance will be longitudinal direction. I mean that is x direction on MIDAS symbol. So punch the 10 for dx. And never forget to check on the merge duplicate node and intersect frame element. And hit apply. And to see all 10 nodes, click the zoom fit on here. And let's move on to creating element. Once you click the create element button on here, you can see those informations. When you're creating your element, you can also define the material and section properties. So click the dot 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 button on here, or you can go to property tab and define the material or section property on here. But today I'm gonna just use a dot 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 box on here. So I'm gonna make the PSC eye girder. So the material property will be 4,000 psi concrete. And sections. Let me create the PSCI first. Also here we have a library on here. Today I will just select the Ashto type number 5 and click OK. And now I'm going to make the composite section. So go to composite tab and click the section type drop box on here and select the composite eye. Here you don't need to punch all the number again. Here you can just click the import button on here and select and import. But here I better to use like inch as length unit. So let me close this one surely and change this one as an inch unit. And go to section property tab again and click the section property button and add like a composite sections. So under composite section tab, select the type composite -I and click the import and click the Ashto type number 5 on here. And you can see the numbers are punched on here. Now let's define the effective width of the deck. So effective width is 110 inch and the thickness of the deck is 8.5 and hunch height is 0. Also, you need to define the node location on vertical direction or horizontal direction on here. So I'm gonna change to offset center to top and click display offset point. Give me a second. Oh, before that I need to define the material property on here. So grade C4000, grade C4000 again, and click OK. And again go to change offset and click the display offset point. Just make sure red dot is on the top of the surface and click OK. Oh, I need to define the name. Now you create a properties, section properties and material properties. So here I'm gonna select the composite eye and click the very first node on here all the way through the the 10th node on here. As you can see here, you can just check whether a gutter line is made well or not through the whiteboard on here. And also you can translate this element, the copy, to the different locations. So first of all, go to top and select all the gutter lines and give me a sec. Go to node and element tab and click the translate element button on here. Here you can use equal distance on unequal distance. So today I'm gonna use equal distance. So distance with like a positive y direction would be 55 inches. And select the check on the copy node attribute and copy element attribute on here. And also number of times will be 4. So as you can see here, 5 gutter lines are created. Now how can you change the section property by using tree menu and table window? First of all, you need to go to tree menu here, and here contains all the material and section property. So just select the element number 5 on here and change this composite eye section to h type number 5. Just click and drag and drop to the whiteboard. As you can see here, sections, this section is changed, and also you can change this one through table window. First, let's open up the element table. Double click this element, and if you want to see the model view and table window at the same time, you can just click the go to tab and click the title vertical on here. So I'm gonna change this element number 1 to this one is a composite eye section. I will change it to section number 2. Section number 2 is composite eye section, and section number 1 is h2 type number 5. So I will change this one to h2 type number 5. So go to element number 1 and change the property number on here. As you can see here, the section, this section is changed. And finally, let me go over what we provide for our clients. We have intro training. As you can see here, it is dedicated to engineers who recently become our users and covers the fundamental modeling and analysis feature of MIDAS Civil. We highly recommend our new users to join this training because we understand the difficulty and frustration from learning something new, especially software. This training will help you to understand what MIDAS Civil is and how it works and its engineering capability. I'm going to open the second intro online training, so please join the intro online training again. And secondly, advanced training for active users. Step-by-step training for modeling and analysis approaches are performed by one of our technical engineers. Lastly, elite engineer webinar. Guest speakers share their modeling and analysis application used in their commercial project. I will cover advanced training and elite engineer webinar in more details in next few